Hello, everyone. Good morning, good afternoon, and good evening. Dear authors and invited guests, welcome to technical session 12E. Myself, Deepika Jain, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 10th International Congress on Information and Communication Technology, ICICT 2025, London, United Kingdom. The 10th edition of the conference has been organized in a hybrid mode. The physical event was held yesterday in London, and the virtual event has been held through Zoom, that is from 19th to 21st February. I hope you will enjoy the knowledgeable sessions and interactive sessions throughout the day. In this session, we have 6 presentations, and each presenter will be given 12 minutes for their presentation and 3 minutes for question and answers. On 10 minutes, I will raise a gentle reminder. I also request the participants to stay connected with us till the closing remarks. If you have any query or update, you can write to me in the chat box. Just before we start the session, I would like to all to introduce to our session chair. Just a minute.
Okay, let me minute to share.
Just a moment, ma'am. I'll let you know. We have our session chair, Professor Sunil Sangve, with us. He is a professor, Department of Artificial Intelligence and Data Science, Vishwakarma Institute of Technology, Pune, India. He has more than 22 years of teaching experience in academics. His area of specialization is network security, data mining, software engineering, data science, and analytics. I welcome you, sir. We also have another chair with us, Professor Ani Rajan. She is presently working with Depe College of Arts and Science, Myanmar, Goa, as an associate professor in the Department of Information Technology. She has been in the field of education for 18 years. Her special interest is in learning management system, tools for teaching, and learning environment. I welcome you all here. To move on with our first presentation, just a moment. We have our first presenter with us who would be presenting a paper on attentional convolutional architecture for brain tumor recognition. Yes, ma'am. Shahad Tariq, are you here?
Yes, I am here.
Please start sharing your screen.
Okay, let me second.
Yes, please.
Can see?
Yes.
Good morning, everyone. My name is Shahad Tariq, and I am a student of Faculty of Computer Science, MSA University. Today, I will presenting my research on attention convolution architecture for brain tumor recognition. This work explore how deep learning, particularly attention mechanism, can improve the accuracy of brain tumor detection using MRI images. Let's get started. Before we dive into the details, let me give you a quick overview um, of today's presentation. Introduction, I will start by explaining the background and importance of brain tumor recognition, motivation, why this research is necessary and how it can help in real time, uh, problem statement, the key challenge we aim to solve, related work, a look at existing method and their limitation, proposal methodology, our approach and how it improves previous work, experiment and dataset, how we trained and evaluated our model, result, the performance of our model and its comparison with other approach, conclusion, key takeaway, and the possible feature improvement. References these sources that contributed to this work. Let's begin with the introduction. Brain tumor are one of the most life-threatening medical condition. Early detected through MRI is crucial for improving potential survival rating and ensure efficient treatment. However, traditional manual MRI analysis has several limitations. It is time consuming, prone to human error, and often inconsistent. While deep learning models, particularly CNN-based architecture, have shown great promise that they still struggle with issues like overfitting and poor feature discrimination. To address this challenge, we propose a deep learning attention framework that integrate efficient net, ResNet, and VGG with multi-head attention. This approach enhances feature extraction, leading to highly accurate brain tumor recognition model achieve an impressive accuracy of 94.94%. Now, let's move on the motivation behind this research. Understanding this motivation behind this research is crucial. Why do we need a better approach for brain tumor detection? Let's look at three key reasons. First, need to accurate and early detection. Brain tumor are life-threatening, and early diagnosis is essential for effective treatment. Detection tumor at an early stage can significantly improve survival rates. Limitation of existing method. Traditional MRI analysis is slow, inconsistent, and highlight dependent on expert interpretation. Even deep learning models like CNN often struggle with feature discrimination and overfitting, leading to suboptimal performance. Third, advancing AI for better diagnosis. To overcome this challenge, we introduce a deep attention framework that integrate multi-head attention. This enhance feature extraction, leading to improved classification accuracy and more reliable tumor detection. With this motivation in mind, it's now define the specific problem we are addressing. Now that we understanding the motivation, let's clearly define the problem we addressing. Traditional brain tumor detection using MRI has several challenges. First, time consuming and error prone. Manual MRI analysis requires expert radiologist, making this process slow and subject to human error. Inconsistency. Different radiologists may interpret the same scan differently, leading to variability and diagnosis. Third, limitation of CNN-based model. Well, deep learning has improved tumor recognition. Traditional CNN struggle with two major issues. Overfitting, where the model learn news instead of magnifical pattern. Limited feature discrimination, which affect the accuracy of classification. This creates a strong need for advanced approach that enhance both reliability and efficient in tumor recognition. To address this, let's now explore some of this method and their limitation. Before introducing our approach, let's look at some existing work in brain tumor recognition. Use tumor recognition, augmentation, and partitioning, which help improve feature extraction and classification accuracy. I had applied deep CNN for medical image analysis, shows that CNN are effective in a capture complex tumor pattern. Sis and Raja focused on CNN-based special feature extraction and confirmed that CNN are useful in medical image. Sharma and Saha used transfer learning with ResNet, which significantly improved classification accuracy. Masivanna further improved model performance through fine-tuning and transfer learning. While this method made progress, there are still challenges like feature discrimination and overfitting. Our proposed method builds on these studies by integrating multi-head attention with CNN to enhance feature extraction, and classification performance. Now let's go through our proposed approach step by step. Step 1, data collection. We collected labeled brain MRI image from a publicly available dataset. Step 2, processing. We resized all image to 640 multiply 640 pixel and normalized pixel value to maintain consistency across dataset. Step 3, feature extraction. We used powerful pre-trained model like FishNet, VGG, ResNet to extract important feature from MRI scan. Step 4, multi-head attention. This is key innovation in our approach. Multi-head attention helps the model focus on the most important feature from the extracted data, improving classification accuracy. Step 5, classification. The extracted feature are fed into a neural network which classifies tumor into magnetic glioma or particular tumor or no tumor. Step 6, module evaluation. We test our module performance to ensure it generalizes well and achieve high accuracy. This approach helps improve the feature extraction and tumor classification, leading to better results compared to traditional CNN models. Now let's go through the experiment setup and how our model processes brain MRI image step by step. Step 1, input MRI image. First, we take the MRI scan and input for analysis. Second step, feature extraction using CNN. We use pre-trained model like ResNet, VGG, and FishNet to extract important feature from MRI scan. Multi-head attention layer. To improve a feature focus, we apply an attention mechanism that highlights the most important region in the image. For feature vector formation, after processing the extracted feature are combined into the magnifical representation, making the ready for classification. 5-step deep neural network classifier. Finally, the feature vector is passed through a neural network that classifies the image into different temper type. This setup ensures that our model focus on the most relevant tumor feature, leading improved accuracy. Dataset overview. For our study, we used dataset consistent of 7023 MRI image for human brain, categorized into 4 classes. Data is best strategy to ensure well-structured train process. We divide the dataset as follow: 50 train set used to train model, 30 validation set used to tune hyperparameter and prevent overfitting, 20 testing set used in evaluate the final model performance in uses data. Classes distribution that be chart in the right show the distribution of classes in the dataset. The percentage are relevability balance, ensuring for representation across tumor type. Why this dataset? This dataset is crucial because it provides diverse MRI scan covering different tumor types, allowing our model to learn robust and generalized feature. Result slide. After training and evaluate different model configuration, we obtain the following accuracy result: ResNet, VGG, FishNet. ResNet accuracy of ResNet 98.2%. VGG 97. FishNet 93. VGG that plus FishNet plus ResNet 98. Best performance. ResNet plus VGG plus FishNet 96. VG plus ResNet EfficientNet. 95. The best model was the VG plus EfficientNet plus ResNet. Combined achieve 98.7 accuracy. In conclusion, this study demonstrates the effective of deep learning models combined with multi-head attention for brain tumor classification. Pre-trained models like EfficientNet, VGG, and ResNet enhance feature extraction, improving classification accuracy. The integration of attention mechanism help focus in critical tumor region, making the model more reliable. Experiment results show that the proposed approach outperform traditional method in accuracy. Feature work exploring additional dataset for better generalization, implementation real-time deployment in clinical setting for enhanced medical diagnosis. This my references. Final, thank you for your attention. Looking forward to your question.
Moving on further, we have our next presenter with us, who would be presenting a paper on enhancing warehouse efficiency with a decentralized UWB and IoT tracking system.
Okay. Yes. Good morning, everyone. Thank you for being here today. My name is Laor Kowawisarat, and I am excited to present our research on enhancing warehouse efficiency with a decentralized and IoT tracking system. This work is done under the National Electronic and Computer Technology Center, NECTEC. Okay. So today I will talk you through the motivation of our research, our proposed system, key findings from field tests, and potential future developments. So Industrial 4.0 is the transform globally supply chain, and Thailand is no exception. However, most of Thailand industrial is still in the level of 2, so Industrial 2.0. With that marks that we have a mass production and assembly line as shown in the picture. Okay, and also this is confirmed by the survey of Thailand Industrial 4.0 Index that most of factories still in the state of Industrial 2. And of course, there is a huge gap between climb up from the Industry 2 to Industry 4. The cost of adoption is one of the concerns, and the problem that common issue for the factory. One of the common issue of the factory will be the visibility of the production line. So they need a challenge to adopt the IoT base for tracking solution. A key challenge is the high cost of the tracking system and making adoption difficult for small and medium enterprise. Our goal is to provide a cost-effective and scalable alternative. Okay, even though from the Thailand IoT market in the year of 2022, the value is 228 million USD and 70 million USD is allocated for the industrial application, but it's only for the big company, and for the small and for the medium and small enterprise is still considered to be very expensive. So with our research will be aimed on develop a decentralized real-time tracking system that enhance the efficiency and reduce costs, specifically focus on 2 objectives. Developing a real-time tracking system that provide precise location and condition update. The other one is to ensure cost reduction and operation flexible through the IoT-based solution. So let's be talking about the existing system. There are many technologies that used for the real-time tracking, specifically for the indoor real-time tracking system. However, the ultra-wideband technology is considered widely used due to the more precision compared to other technologies such as RFID or BLE. However, the existing tracking system of ultra-wideband are centralized infrastructure. As you seen on the left-hand side, the tag will collect the data from the anchor, which is attached to the wall or the ceiling, and they will relay update their location via the gateway to the cloud server. That means when in practice, on the right-hand side, when the gray dot is represent the anchor that we install in the one big area, and the green square will be represent the gateway that we have to extra install to make sure that the tag will be updated to the cloud in every area that the tag is travel. So we propose another way is combine the tag with the gateway. That means it can update freely, and as you see on the right hand side, you don't need to have the gateway to install in the area. So this will be one of the cost reduction. And for the hardware side, the Tag Plus that we call will consist of the main processor for the data management, ultra-wideband module for the location tracking, and sensor to monitor the environment conditions such as the battery usage or the temperature or the accelerometer. And we use the 4G or 5G communication module for real-time update. For the communication protocol between the tag to the clouds, the existing protocol will use the IEEE 802.15.4, which is the super frame, and that will update. The frequency of the update will be the same at the location, which is not suitable for some sensor. And so we change it to be the MQTT under the TCP/IP protocol. In this case, the Tag Plus will be broadcast the location and the sensor information separately, and the user can subscribe separately which information they want to know. Okay. So make it more flexible for the update data. And for the software architecture, will be we have the location engine that determine the object position in the map, and performance analytic module for efficiency tracking, a web dashboard for real-time visualization. So to evaluate our system, we conduct the field test at one of the automobiles assembly line in Thailand. And the test area will be in the square, green square, rectangular. And we install 6 anchor and 1 Tag Plus that on automatic guide vehicle or AGV. And the red line will be the magnetic route that this AGV travel. So this AGV is the old model, so it cannot update where it is and cannot tell about the battery usage. So what happened is sometimes it die on the way to work, and it make the worker have to find out where it is. So with our tracking system, then now they can know where is this AGV, and the location is as good as the centralized model. Okay. Besides that, they also have knowing the information about the battery usage and the route, which route that the AGV travel the most, and the distance that AGV travel, as well as the temperature. In terms of cost equipment, we calculate in the 2,000 square meter area, and it can be seen that our proposed method is cheaper by 37% compared to the existing system. Okay, so we have proposed the decentralized design to reduce cost and enhance scalability. So hopefully this will support the SME in transition to the industrial 4.0 with the minimal investment. However, our system is rely on the cellular network for real-time update. That means if some area that have poor connectivity, it will be a problem. Okay, so in conclusion, our decentralized IoT tracking system offer a cost-effective and scalable solution for operation. It significantly improve real-time asset tracking and provide flexible for the SME. With the challenge that we face, so in the future world will be include the machine learning to enable the prediction analytics for the operation, and also explore hybrid communication networks such as the cellular network and mesh technology. So thank you for your time. So any question?
Thank you, ma'am. Thank you for the presentation. Any questions, sir or ma'am?
No, ma'am. From my side, no questions. Thank you.
Okay, sir. Any questions, ma'am?
Yeah, have you made
Anything?
any comparative study in on field with other data, means other algorithms or?
We actually before this we use the centralized one that with the gateway and the tag is attached to the AGV, and then we have a problem when there has a very big area. We have to install the gateway, and we have problem about when the access point is not the same IP land. They have
So
some
have you
problem with that.
have you done any field study with the existing algorithm?
Yes, we did, but we didn't. We did it with the other. I mean the factory, not in this one. This one after we faced the problem, so we used this one to this factory.
Okay, thank you.
Thank you. Thank you, ma'am. Thank you. Moving on further, we have our next presenter with us, who will be presenting a paper on jailbreak attack on a multi-agent LLM defense system. Yes, sir. Are you here?
Yes, I do.
Yes, sir. You can start sharing your screen.
Can you see my class slides?
Yes, yes.
Thank you. Hi, everyone. My name is Junichiro Ando, and I am from INIAS, Toyo University. Today, I will present our research, jailbreak attack on a multi-agent LLM defense system. Here is overview of today's presentation. And first, I will talk about the motivation and background of our research. LLM such as ChatGPT have attracted attention for their excellent content generate capabilities and are widely used in various fields. However, LLM also have the risk of generation harmful, unethical or illegal content. To mitigate these risks, safety mechanisms called guardrails have been introduced. However, these guardrails are vulnerable to attack calls, jailbreaking. Several countermeasures against jailbreaking have been proposed by using a multi-agent LLM defense system, such as auto defense. We would like to propose a new jailbreaking methods against auto defense. From these slides, we will explain the relational knowledge. First, we will talk about jailbreaking. Jailbreaking is an attack method that uses specialty crafted prompts to bypass safeguards and make LLM generate inappropriate contents. Numerous techniques have been deployed, including prefix injection and rejection suppression. Next, let us introduce relation work, or defense. Or defense is a multi-agent defense framework that filters harmful response from LLMs. It increases robustness and prevents jailbreaks by using multiple agents and giving each LLM a specific role. Next, we will discuss relation work. Many researchers have been working on jailbreak defense. First, Jan proposed jailguards, a jailbreak detection system that supports both text and visual inputs. Next, Zhao proposed layer-specific editing, LED, a defense mechanism that enhances LLM resistance to jailbreak attack by modifying specific model layers. From these slides, I will explain our proposed methods. This image shows the overlay flow of the proposed methods. First, all defense is a system that checks the output of the victim LLMs, verify whether the output is appropriate, and judge it as valid or invalid. Our proposed methods focus on jailbreaking odd defense with malicious prompts. If odd defense judge an inappropriate response is invalid, it can be said the jailbreak of the proposed methods was successful. First, I will talk about the datasets. To evaluate the proposed methods, we use dataset calls in the wild jailbreak prompts on LLMs. It contains 319 harmful questions from 13 categories. For example, illegal activity, fraud, and malware generation. Below is a sample of the dataset. Next, we'll explain the specific methodology we propose. Because the OS defense is robust to existing jailbreak techniques, we introduce the additional technique to bypass them. The first is obfuscating malicious outputs. After user denial suppression and prefix injection, the victim LLMs hide in outputs, making it more difficult for auto defense to understand. However, auto defense may still recognize this as an attempt to conceal harmful contents or decode it can cover the malicious intent. In this paper, we employ 4 difficult obfuscation techniques: URL encoding, base encoding, hex encoding, and lot encoding. Measures the detection evasion rates of each technique. The second is appending benign text to the obfuscated contents. To overcome the weakness of obfuscation, we instruct the victim LLMs to allow harmless text because of obfuscated malicious content. For example, insert the text shown blue on the slides. This will ensure that the initial final output of the LLM always starts with this text. This limits that LLM's reading comprehension and weakness the guardrails. Finally, we will discuss our evaluation matrix, ASR. To evaluate the detection evasion rates, we use attack success rates, ASR, as in previous studies. This calculates the percentage of prompt successfully defended by odd defense, and is shown in this slide. We compare the 2 methods to measure the ASR. 1, only obfuscating the output of the victim LLMs, and 2, our proposed methods. Through these evaluation and comparison, we clarify the effectiveness of our proposed methods. Around this slide, I will explain the conclusion and results of our research. This table shows the ASR evaluation results of classification only as the proposal methods. Note that it's this on a study. Experiments were conducted with for encoding. The proposal methods achieved maximum accuracy of 95.3%, compared to the conventional 18.5%. The graph above have been turned into a table. As you can see, it's clear that our proposal methods, which combine obfuscation and the addition of benign plain text, subtly improves SR over all obfuscation technique. Finally, a conclusion. In this paper, we propose evaluation and novel jailbreak methods designed to circumvent the odd defense, multi-agent defense framework. We demonstrated a dramatic improvement in ASR. And these results clarify the needs for more robust and adaptive defense system to safeguard LLMs against increasingly sophisticated attacks. As a future work, we would like to further improve the input prompts of the victim LLMs to improve the decoding success rate and ASR. Thank you for attention.
Yes, sir. Thank you so much. Any questions, sir? Any questions, ma'am?
So yes, if I am audible, I have one question.
Yes, sir, you're
Yes.
audible.
I'm audible, ma'am.
Sir, you're audible, sir.
Yes. So yeah, I have a question to the researcher that how many images and text messages are considered for evaluating the success rate as compared to the existing one?
Yes,
Yes.
right?
So my question is, how many images you have considered for evaluating the success rate for your proposed method? After considering that number of these images, depending on which you are going to conclude your proposed method experimentation, whatever the experimentation you have done, because as compared to the existing which shows the result as 18.5, whereas your result comes to near about to 95.3%. So how many images are you have taken as compared to the existing method
You mean that the
for the
sample,
experimentation?
you mean that you are asking the number of samples we use in our experiment, right?
Yeah, number of
Yeah.
samples for images or text messages like
Okay.
that.
So wait a moment. Yes, sure it is. So we use this data set. It contains 390 harmful questions from 13 categories, and it is so-called
Okay.
wild jailbreak prompts on LLMs. Am I right? Is it a correct answer for your question?
Hello, sir. All right. Thank you, sir. Thank you for the presentation.
Thank you very much.
Thank you very much.
Yes, sir. Any other questions, sir? Moving on further, We have our next presenter with us who would be presenting the paper on sentiment analysis of tourism village amalgam from online review platform using large language models. Yes, ma'am. Hannah?
All right. Thank you for the opportunity to present my research about sentiment analysis of tourism village amalgam from online review platform using large language models. My name is Hannah Ulin Nuha and I am a faculty member of Tourism Study Program of BINUS University in Jakarta, Indonesia. Let me start with a little bit background of this research. Recently, tourism villages are central to Indonesia's tourism development strategy, contributing significantly to local, regional, and even national economic growth. With the increasing number of tourism villages, understanding tourist perspectives is essential for ensuring their sustainability. So to ensure the sustainability of tourism village, one should focus on market's perspective of tourism village. And measuring market's opinion of a tourism village can be pursued in various ways, one of which is by observing tourist reviews of tourism village on online review sites. Therefore, we use sentiment analysis to do this. So this method is used to extract and identify opinions from text, especially in online reviews and social media posts. The method is used to understand customer opinions, detect sentiment polarity, and identify patterns that might not be visible to humans. But first, what is tourism village? In Indonesia, we call it by desa wisata. Tourism villages are a form of community-based tourism institution in Indonesia. Community-based tourism is relatively a new form of tourism that integrates communities with small businesses and companies with all revenue streams directly benefiting the community, which provides all services. The concept of tourist villages was developed to promote sustainable tourism as a means of alleviating poverty in line with the Sustainable Development Goals. And currently, tourism villages receive special support from government agencies and private organizations in Indonesia. Sentiment analysis has been applied in various countries in increasing interest in this topic and a focus on understanding the impact of online reviews on decision making, the resources used for sentiment analysis, methodological approaches, and the role of the internet in tourism. Despite growing research, sentiment analysis remains underutilized, especially in tourism village development. In this research, we use tourism amalgam to help us get insight into which components got more positive or negative review from tourists. The components are attractions, amenities, accessibilities, and ancillary services. These 4A, called also by tourism supply. So what we did first was web scraping. We used Python to help us gather the data from Google Map reviews, filtering, and categorizing. The keywords was desa wisata or tourism village. The data was collected on July 2024. We used large language models as a technique. The process included feature extractions, sentiment classifications, and model evaluation. We also validated the results by comparing with the transformer architecture, especially Distilbert. Finally, we translated the results into English using Llama 3.1 since the original text is in Indonesian. And here is the result. Examining the year-over-year review data, the highest number of reviews for tourism villages occurred in 2019, then dramatically declined due to the impact of COVID-19. And the majority of reviews were rated 5, comprising 65.5% of the total, followed by ratings of 4 at 22%, rating 3 at 8.7%. The rating were then converted to sentiment categories for comparison with the LLM's analysis results. Rating of 4 and 5 were classified as positive, rating 3 as neutral, and rating 1 and 2 as negative. The ratings were then converted to sentiment categories. And after conversion, the sentiment distribution was 87.5% positive, 8.7% neutral, and 3.8% negative. The results generated by the LLM model's GPT-4o mini show that it's classified reviews into 3 sentiments: 78% positive, 13% negative, and 9% neutral. Compared to the sentiment contribution from the converted ratings, the GPT-4o mini models classify fewer reviews as positive, with a discrepancy of approximately 10%. Overall, the similarity between the sentiment analysis results of GPT-4o mini and DistillBird is 80%. Excluding the neutral sentiment, the similarity for positive and negative sentiment is 88%. This comparison demonstrates that the GPT-4o mini models performs well in sentiment analysis of reviews and is suitable for use in this study. And for the 4A analysis, the analysis of review based on the 4A's components indicates that the most visitors focus primarily on destinations attractions, which is 67%. The analysis also revealed that the review typically do not cover only a single component. Travelers often discuss multiple components with a single review. The combination of the attraction and amenities components is the third most frequently discussed in reviews, followed by the combination of attractions, amenities, and accessibility in 5th place. And the figures also shows the presence of nothing components. Those are the reviews that do not discuss any of the 4A's components, making them too general for classification by models. For example, the brief comments like not bad or okay. The third picture here in the slides indicates that the different components and their combination yields varying sentiments. Reviews focusing on attractions alone, for example, or in the combination with other components generally yield more positive sentiments than other types. This underscores the importance of attractions in receiving positive reviews. So when the attractions are appealing and leave a strong impressions, travelers are likely to provide positive feedback and concentrate on discussing the attractions, which can enhance the sentiment associated with other components as well. So here is the correlation analysis between the 4A's components and sentiments. The tourism village managers could strategize to highlight their attractions. If the attraction is less prominent, other components should be emphasized. For instance, under amenities, managers could enhance unique accommodation, such as offering traditional homestays with local families or ensuring high standards of cleanliness. For accessibility, managers could seek partnerships with local authorities to improve access to the location, such as providing public transport options or ensuring well-maintained roads. Because negative sentiments around accessibility is understandable if reaching the destination is challenging and the attraction itself is underwhelming, as visitors may focus on the unpleasant journey. And conversely, if the attraction is compelling, visitors often feel that the journey was worthwhile, directing their attention toward the beauty of the experience.
Dear presenter, you have
Yeah.
2 minutes left. Can you please conclude as soon as possible?
Okay, so here is an in-depth analysis for each of the 4A components to provide insight for tourism village. For example, the attraction, the words village and place, cool, beautiful, and nice are the most frequently used by visitors to describe tourism villages, suggesting that the village itself is a significant draw for visitors. These terms indicate that visitors enjoy finding places that are beautiful, cool, attractive, which can be a key selling point for tourism village. So to summarize these presentations, utilizing LLM for sentiments and for a tourism component analysis is highly effective. The GPT-4o mini LLM can classify reviews into positive, neutral, negative sentiments, and the model also effectively classified based on the 4A tourism components, even combining components when reviews cover multiple aspects. So results also show that the attraction component leads with 67% of reviews, followed by the amenities 21% reviews, accessibility 9%, and ancillary only 3%. Attraction generates the most positive reviews, while accessibility tends to receive the most negative feedback. For this research, especially the ancillary component keywords, there are many similar themes. Review with amenities. Ancillary services are those that support tourism activities, which may include public facilities. Therefore, it leads to redundant keywords. So for further research, it is recommended that we need to merge ancillary with amenities components. And other research topics such as tourist behavior would be interesting to investigate using the same method. Thank you for your attention.
Thank you, ma'am. Any questions, ma'am? Any questions, sir?
No, ma'am. From my side, there is no question.
Okay, sir. Any questions, ma'am?
Yeah, now you have done the sentiment analysis by just using large data set from what you extracted from, as you said, you have extracted data, no?
Yes, yes.
So you did not do any kind of groundwork. Just what people have put comments, you have extracted that and found out the sentiment. Hello?
Yes, all the sentences.
Yeah, that is all the sentences available online.
Yes.
Okay, fine.
Moving on further, we have our next presenter with us who would be presenting a paper on the impact of social media usage on the mental health and social behavior of young adults, a systematic literature review. Yes, sir.
Thank you so much, and good morning to everyone. My name is Timothy, and I'll be presenting this paper titled The Impact of Social Media Usage on Mental Health and Social Behavior of Young Adults, a systematic literature review. I'll start up with the agenda with a brief introduction, the research gap, related works, methodology, result, and conclusion. Now, the use of social media platforms today, we can see, is part of our day-to-day life. And the rise and use of social media platforms have been shaping how we interact, how we share information, and how we perceive ourselves. Young adults have become highly susceptible to social media usage, using it for entertainment, social support, communication, creativity, and professional pursuits. However, social media use has brought some detrimental effects such as depression, anxiety, and stress, among many others, which we'll be looking at very soon. So the primary research question is what is the impact of social media usage on the mental health and social behavior of young adults? The research gap we found is that most research focuses on general impact of social media, but does not adequately address variations across different demographic subgroups within the young adults population, such as the gender, socioeconomic status, and cultural background. And despite extensive research on the relationship between social media usage and mental health, gaps remain in understanding the nuanced mechanism through which social media influences young adults psychologically and how it affects their social behavior. So addressing these gaps is critical to develop a targeted evidence-based intervention that mitigates the adverse effects, also while maximizing the benefit of social media usage. In my related works, we can see that the use of social media of young adults has impacted on their mental health, some positively and negatively. The upside can aid in building connection. That's the positive aspect, boosting self-esteem and creating a sense of community, a sense of belonging. However, the downside to mental health issue due to comparison by young adults to perfectly curated content. We can see it causes digital distress. Sometimes they experience cyber victimization, which can lead to suicidal ideation, self-inflicted damage, and internalizing and externalizing issues. So in order to fully understand the impact that social media has on mental health and well-being of young adults, different moderating factors must be fully understood. And that's enabled us to conduct what we call a systematic literature review, extracting data, information, factors from 3 databases: Web of Science, Scopus, and EBSCOhost. And these data are chosen, or the papers for this extraction are chosen based on high-quality journals. And the search term we used is on the second point. And from Web of Science, we were able to return 1,088 results based on that search term. On EBSCOhost, we were able to return 162 results. And on Scopus, we were able to return 1,235 results, giving a total of 2,485 journals. And we did some inclusion and exclusion criteria. The inclusion criteria comprise the papers that align with the research objective. It must be definitely peer-reviewed and it must be open access. And papers that did not align with the research objectives and topics or not peer-reviewed or that are not open source were then further excluded. But in some instances, there are some duplicates. We make use of Prisma approach to eliminate duplicates. And at the end of it all, we were left with just 25 papers to analyze. So in my table 1, it's a summary of the effect of social media and the authors who support these findings. We can see that the prevalent effects include positive outcomes such as social connectedness, social support, enhanced self-esteem, and the negative impact like depression, anxiety, fear of missing out, self-harm content, sleeping quality, anxiety. These are factors that we picked up that significantly affect these young adults. And one prominent negative effect is the fear of missing out, which significantly impacts psychological well-being of young individuals. Fear of missing out arises from the anxiety. Here we're looking at the relationship between some factors. That fear of missing out arises from the anxiety of potentially missing rewarding experience, leading to compulsive social media usage. And we can then see that anxiety becomes a recurring theme in the research, often linked to excessive social media use. Young adults who frequently check their phones, see curated posts of peers enjoying life may experience feelings of inadequacy, reinforcing fear of missing out and heightening anxiety level. Cyberbullying, cyber victimization, they are also negative consequences of social media. So the self-harm is also a very big one that we picked up. Is another prevalent negative effect of social media. The platform often exposes young adults to triggering content that normalizes self-harm. In fact, some individuals even go on social media to search for methods of suicide. So these are the negative effects of social media that we picked up in our study. So we came up with a framework called the Dual Impact Framework of Social Media on Mental Health. So this finding informed the development of a conceptual framework called the DIFSM, that's the Dual Impact Framework of Social Media on Mental Health, as we can see here. The framework illustrates the dual nature of social media effects, with the negative impact outweighing the positive. The framework emphasizes the nuanced role of self-esteem. The self-esteem, if you can see, is in the middle there. It's in the middle here. It's saying it's neutral. It can be positive, it can be negative. So when we then talk about, for instance, upward comparison, common on platforms like Instagram often diminish self-esteem, whereas downward comparison, which will boost self-esteem, are less frequent. The ripple effect of social media negative consequences is evident in the framework. For example, anxiety triggered by social media usage can escalate into depression and poor sleep quality. Similarly, we can see cyberbullying exacerbated by the prevalence of online trolling. It's also linked with self-harm behaviors and exposure to harmful self-harm content. So these are the relationship we are able to bring out based on this framework to see how fear of missing out can lead to anxiety, how the anxiety can then lead to depression and sleep quality, how cyberbullying can lead to self-harm or self-harm, lead to the use of engaging self-harm content and self-harm. So in conclusion, the research findings indicate a delicate balance between positive and negative impact of social media on the mental health and well-being of young adults. However, based on the factors we're able to extract using the systematic literature review approach, the negative effect appears to be more dominant, often overshadowing the benefits. The risk associated with social media usage are, I would say, it's significant and it warrants urgent attention. And based on these findings, proactive measures is then necessary to be put in place in order to mitigate the adverse effect on young individuals' psychological well-being while preserving its potential benefits. Thank you so much, and that's all from my side. I'll take any question from.
Thank you, sir. Any questions, sir? Any questions, ma'am?
No, ma'am. Well explained and very understandable concepts. Thank you.
Thank you. Okay. Do we have the presenter of this paper here? Enhancing English learning in primary education, evaluating Scratch as a pedagogical tool. Any presenter of this paper here? All right. Just a moment. Okay, so we have come to our closing remarks. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 10th version and all the previous 9th versions of the conference. We will be happy to see you in the 11th version as well. All the presenters will be getting their digital certificates through email within 2 working days, and the papers have been already forwarded to the Springer board, and the publication will be live within 6 months. So kindly cooperate with the team of ICICT 2025. I also thank our session chairs. Thank you so much, Annie Rajan ma'am, for chairing this session. This is a token of appreciation to you from the Global Knowledge Research Foundation
Thank you.
and their partners and the team of ICICT. Thank you, sir. Thank you, Sunil, sir. Thank you so much for your presence. This is for you, sir. Thank you so much.
Thank you, ma'am.
Thank you, sir. Thank you for chairing the session. It was great to have you both here. Thank you so much. I just kindly request if the participants can turn on their cameras for a quick snapshot, please. Thank you. Thank you, everyone. Thank you so much. Take care. Bye-bye. Thank you.